Okay, in this video we're gonna talk about how to solve a logarithmic equation. These are the steps for solving logarithmic equation. First, what you want to do is you want to simplify the logarithm as much as possible. That means sometimes you have two logarithms inside in the equation, like that one. So you want to simplify that as one logarithm. That's actually typo. That's LOG, not OG. So once you have just one single logarithm, then you want to convert that into exponential equation. So, and then after you convert that, you want to solve for x. In other words, just find x. And then once you found the values of x, you want to check the answer. Checking for the answer in the logarithmic equation is kind of important because there are extraneous solutions. So when you check the answer, you want to check to see if the argument of the original equation, so that's the argument for x minus 3, if the argument turns out to be positive or not, because in logarithm argument must be positive. If you plug in a number and then the argument turns out to be negative or 0, then that's not a valid solution, so you want to exclude that. Another thing to check is, like all other equations, you want to see if the equation is true or not. That's pretty kind of general. So you want to be careful with the argument. So let's look at the first example. Since this is just one logarithm, we want to just, this is simple enough, so you want to convert this into exponential equation. So since we do not have any base, that means base is 10. So base 10 to the power of 2 is equal to 4x minus 3. Well, we know 10 to the second power is just 100, so I'm just going to write that. Now I can just solve this for x, which is just basic algebra. So 4x is equal to 103, divide both sides by 4, I will get x is equal to 103 over 4. So we got the answer. We want to check the answer. So if I plug this x into our original equation, I'll get log base 10, or you don't have to write 10, 4 times 103 over 4 minus 3. Well, 4 and 4 cancels each other out, so I'll just have log base 10 of 103 minus 3 is 100. Okay, 10 to what power is equal to 100? So 10 to the second power equals to 100, so the value will be 2, which is exactly what the right side is about 2. So we know this equation is true, and then we know when we plug in this number, the argument turns out to be positive number, which is 100. So there's no problem with this solution. So that's our final answer. Let's look at the second example. These are just similar kind of problem. This is a similar kind of problem. I just wanted to go over this one because the value of this logarithm is negative, so it's just a little bit different. Again, we only have one logarithm, so we do not have to simplify anymore. So I'm just gonna convert this to exponential equation. The base is 10, so 10 to the power of negative 2 is equal to the argument, which is 1 minus x. Well, base 10 to the negative 2 power is same thing as 1 over 10 to the second power, because the exponent is negative, we flip the base, so it becomes 1 over 10. So that's just 1 over 100. So I'm just going to rewrite 1 minus x is equal to 1 over 100, so, or I'm just going to write 0.01. Now I can just add x to both sides. I will get 1 is equal to x plus 0.01, subtract 0.01, I will get x equals to 0.99. Okay, let's check our answer by plugging in. So if I plug in here, log base 10 of 1 minus 0.99, what does that equal to? Well, that's just 0.01. So we know the argument is not negative, so this is okay, right? So it passes that test. So 10 to what power is 0.01? Well, we know 10 to the negative 2 power is 0.01, because like we said here, 0.01 is same thing as 1 over 100, which is 1 over 10 to the second power. Because this is 1 over 10 to the second power, this is negative 2. which is right exactly same as the right side. So we know this is the correct answer. Okay, let's look at the next example, which is maybe a little more complicated than the previous one, but we just have one extra step, which is to simplify. Because we have two logarithms in this equation, we want to simplify that to one single logarithm. So we can use our product property of logarithm. If two logarithms are added together, we can just multiply the argument and make it into one logarithm. So I can combine these two logarithms to log x minus 3 times x. I'm just going to write x in front and then x minus 3 later, because that's more conventional than writing x minus 3 times x, is equal to 1. Now we have one single logarithm. We can convert this to exponential equation. Now we look at the base, which is 10 because there's no base. So 10 to the power of 1, which is 10, is equal to x times x minus 3. So I'm just going to write 10 over here and solve this. Now this is just a plain quadratic equation, so we can distribute x. I'll get x squared minus 3x, and then I can subtract 10 from both sides. I'll get minus 10 is equal to 0. Now we can just try to factor what are the two numbers that multiply to negative 10 and add to negative 3. Well, they are 2 and 5. So since that's negative 3, this should be negative, that should be positive. So x plus 2 times x minus 5 is equal to 0. X must be negative 2 or 5. Okay, now we got these answers. Now it's time to plug in and check our answer. So we have to see if the argument is positive or not, or also see if the equation holds true. So let's try with negative 2 first. If I plug in negative 2, I'll get, well, just be careful, we have to use the original equation, which is this one, not this or that. So if I plug in negative 2, I'll get log negative 2 minus 3, which is negative 5. We end up with negative argument. That means this answer is not valid. We don't really have to keep going on because this is already wrong. So we can exclude that. Just notice that this is invalid not because that number is negative. This is invalid because this number x minus 3, which is the argument, is negative. So that's the reason why this is wrong. And then let's plug in 5. Just because one answer is wrong, that doesn't mean that the other answer is correct. They might turn out to be both wrong too. So let's plug in 5 into our original equation. So log x minus 3, which is 5 minus 3, is 2. Okay, good, we have positive number. Plus log x, which is just 5, is equal to 1. Well, they both have positive argument, but let's just check if that's really true, because we might have made a mistake. So two logarithms are added together. That means I can multiply those arguments. So 2 times 5 is 10, and the base is 10. 10 to what power is 10? Well, 10 to the first power is 10. So we know that this equation is true. So 5 is the final answer.